In the desert, thirst is brutal. Imagine finding water, but it's undrinkable, bitter. The Bible narrates such a miracle. The waters of Marah were sweetened by a tree. Was it magic or a natural chemical solution? Let's unravel this mystery. The book of Exodus, one of the foundational narratives of the Old Testament, describes the monumental journey of the people of Israel. After their miraculous liberation from slavery in Egypt, under the charismatic leadership of Moses, this multitude of newly freed individuals embarked on a challenging trek through the desert of Shur. This was no idyllic stroll, but a severe ordeal imposed by an unforgiving environment. The vast, sandy, and stony expanse stretched under a scorching sun, with extreme temperatures day and night, and, above all, the scarcity of basic resources, especially potable water, turning every step into a test of faith and endurance. For 3 long days, the march continued, the hope of finding an oasis pulsating in everyone's heart. Thirst was a constant companion, a searing pain that sapped strength and patience. When they finally sighted a place that seemed to be salvation, Marah, the momentary relief turned into bitterness, both literal and figurative. The waters of Marah were, according to the biblical account, undrinkable, unfit for human consumption. The taste was so repulsive that it rendered them useless for quenching thirst. This bitterness was not just an inconvenience. It was an alarming sign of potential toxicity, an imminent risk to the health and very survival of an exhausted multitude. Despair fell upon the camp, and murmurs of discontent and hopelessness quickly spread among the people, who had witnessed so many miracles but now faced a brutal reality. The biblical description is concise, yet the power of the words echoes the feeling of that moment. When they came to Marah, they could not drink the water because it was bitter. That is why the place was called Marah. The name of the place, Marah, meaning bitterness, sealed the memory of this episode. The people's cry to Moses, their anguish in the face of imminent dehydration, and the fear of a tragic end in the middle of the desert, all converged on an existential problem: how to transform the undrinkable into potable. The situation was critical, and Moses' leadership was under immense pressure, with the people's faith tested to its limit. For the modern mind, this gap in the description, the absence of details about the chemical nature of the bitterness, prompts a search for explanations that transcend pure miracle. If the waters were bitter, what was the cause? Was it an excess of dissolved minerals, such as magnesium sulfate or calcium, which impart a metallic and unpleasant taste? Or perhaps the presence of toxic organic compounds, a product of decaying plant matter in a desert environment, or even contamination by specific microorganisms that released bitter substances? The lack of a more technical description in the Bible is understandable, given the cultural and scientific context of the time, but for us, it becomes an invitation to investigation. The account at Marah is not just a passage of faith, but a fascinating ancestral case study of a hydrological engineering problem. It invites us to delve into the possibilities of a natural solution to a challenge that, at first glance, seemed insurmountable. The episode serves as a perfect introduction to our investigation, establishing the problem dramatically and the urgent need for intervention, whether perceived as purely divine or, as we propose, with a strong component of natural chemistry. The urgency and despair of the people of Israel at Marah underscore the vital importance of finding a quick and effective solution for water potability. At the height of the Israelites' despair in Marah, the biblical narrative describes a crucial moment of intervention that would change the course of events. Moses, faced with the outcry and the impending water crisis that threatened the lives of the entire community, turned to the Lord for a solution. The divine response, though seemingly simple in its description, is profoundly enigmatic and central to our analysis. And the Lord showed him a tree, and he threw it into the water, and the water became sweet. This single, seemingly unassuming sentence opens the door to a fascinating inquiry into natural and chemical properties. Here, the tree or bush mentioned in the biblical text becomes the protagonist of our investigation. What could this plant be, possessing such extraordinary properties? The action is described with remarkable simplicity, merely casting a piece of wood into the water. But the resulting effect is of impressive complexity. The transformation of bitter and, presumably, undrinkable water into potable water. The Bible, focusing on the dimension of miracle and divine providence, does not specify the botanical species, which allows us to delve into the realm of scientific speculation, seeking parallels in nature that might elucidate this miracle from a more rational and biological perspective. The Sinai Desert, where Mara is located, is a harsh ecosystem, yet it boasts a remarkably adapted flora that thrives in extreme conditions. Many plants in this region have developed complex secondary compounds, metabolites that are not essential for the basic growth of the plant but serve specific purposes, such as defense against herbivores, attraction of pollinators, or in our case, interaction with the surrounding environment. Could it be plausible that some of these plants possessed flocculating, adsorptive, pH neutralizing, or even chelating properties? The biodiversity of the desert, though seemingly sparse, hides a wealth of biochemical solutions. Let's consider examples of plants known for their purifying capabilities that, even if not from that exact geographical location, demonstrate nature's abundance in offering such resources. Moringa oleifera, though native to India and Africa, is a prime example. Its seeds contain cationic proteins that act as natural coagulants, clumping suspended particles and causing them to settle. If the bitterness of Mara's water was partly due to suspended solids or compounds that could be carried along in this process, a plant with similar functions would be incredibly effective. Other possibilities include species of acacia, abundant in the Sinai region and surrounding deserts, which produce gums and tannins. Gums can have flocculating and agglutinating properties, while tannins, due to their astringent nature and ability to react with proteins and metal ions, could neutralize the bitter taste or precipitate undesirable substances. There are also plants with chelating properties, capable of binding to heavy metal ions that could contribute to the water's bitterness and toxicity, rendering them inert or less soluble. Furthermore, some plants contain compounds with antimicrobial action, which could disinfect the water from pathogens. The key to the transformation at Mara was not just the removal of bitterness, but the assurance of potability. If the bitterness stemmed from an excess of mineral salts, the plant might have had compounds that would precipitate these salts. If it was due to organic compounds, perhaps enzymes that degraded them. What was crucial was that the water became not only palatable, but safe for the consumption of a large moving population. From this perspective, the miracle gains a new layer of interpretation. Divine providence could have operated through existing natural means, providing the knowledge or revelation about the use of a specific plant that possessed the necessary chemical properties. This view does not diminish faith. On the contrary, it enriches it, suggesting a profound harmony between the divine and the intrinsic laws of nature. Moses' act, guided by a higher instruction, becomes a practical application of ancient botanical and chemical knowledge, a remarkable example of how nature can provide the most ingenious solutions. The central question that continues to intrigue us is, what substance or substances present in this tree could have been responsible for such a powerful and effective transformation? And how was the knowledge of this specific plant conveyed or revealed at such a crucial moment? To unravel the enigma of Mara from a scientific perspective, it's fundamental to first understand the chemical causes of bitterness in water and, subsequently, how a natural intervention, such as that of a tree, could mitigate them. Bitterness is a complex taste, and in water, it can be attributed to various sources, many of which indicate quality problems and even toxicity. The most common causes include the presence of dissolved mineral salts in high concentrations, such as magnesium sulfate, which is a known laxative and has a characteristic bitter and saline taste. Other salts, like excess sodium chlorides or calcium and magnesium salts, can also contribute to an unpleasant taste and a rough mouthfeel. Groundwater or well water in regions with geological formations rich in gypsum, limestone, or other sulfated and chloride minerals are particularly susceptible to this condition. Beyond inorganic salts, organic compounds from decaying plant matter, such as tannins, lignans, and other polyphenols, can impart a bitter, astringent taste to water, and at times, a brownish coloration, indicating the presence of humic and fulvic acids. In more concerning scenarios, the proliferation of algae and cyanobacteria in stagnant water bodies can release toxins that not only cause bitterness, but also pose serious risks to human and animal health, affecting the liver and nervous system. Finally, contamination by heavy metals, such as iron, manganese, or copper, even in concentrations that are not visually obvious, can result in a metallic or bitter taste, and many of these metals are highly toxic. How, then, could a tree neutralize or mitigate these substances so effectively and rapidly as the biblical account suggests? Nature is an unparalleled green chemistry laboratory, and various plants have developed sophisticated mechanisms for interacting with their environment, including water purification. Let's explore the possible chemical mechanisms involved, considering the required speed and efficacy, adsorption and flocculation. Many plants, when immersed in water, release polysaccharides and proteins with long, molecular chains that are often electrically charged. These molecules act as natural flocculating and coagulating agents. They possess an electrostatic or hydrogen bonding affinity for suspended particles, be they fine minerals, clay, particulate organic matter, bacteria, and even viruses, which generally have opposite charges or binding sites. By binding to these particles, the plant molecules neutralize their charges, promoting the formation of larger and denser aggregates called flocks. These flocks, being heavier than water, rapidly settle to the bottom, leaving the water clearer with lower turbidity, and crucially, less bitter, as many of the bitterness-causing substances may be bound to these particles. The seeds of the aforementioned Moringa oleifera are a remarkable and well-studied example of this mechanism, with their cationic proteins acting as natural coagulants. pH neutralization and buffering. If the bitterness stemmed from an excessively acidic or alkaline pH, some plants might release substances that act as natural buffers. Buffers are solutions that resist large changes in pH when small amounts of acid or base are added. By releasing controlled quantities of acidic or basic compounds, the plant could adjust the water's pH to a neutral range, making it more palatable and safe for consumption. Some trees have bark or leaves rich in organic acids or salts that, upon dissolving, could influence the acid-base balance of the water. Inappropriate pH can not only cause taste issues, but also affect the solubility of minerals and the toxicity of certain substances. Complexation and chelation. Certain plant compounds possess the remarkable ability to complex or chelate metal ions. This means they form stable chemical bonds with these ions, encapsulating them or binding to them in such a way that they become less reactive, less soluble, and therefore less toxic or responsible for the bitter taste. If the bitterness was caused by dissolved heavy metals or specific minerals, chelation would be a crucial detoxification mechanism. Many organic acids and phenolic compounds present in plants have this capability, forming soluble or insoluble complexes that can be precipitated or simply rendered harmless. Enzymes and tannins. Some plants produce enzymes that can degrade complex organic compounds, breaking down the molecules that cause bitterness into simpler, less offensive substances. For example, hydrolytic enzymes could break bonds in larger molecules. Tannins, abundant in the bark and leaves of many trees, are polyphenols with astringent properties. They can react with proteins and other organic and inorganic compounds in the water, precipitating them or neutralizing their effects. In appropriate concentrations, tannins can alter the perception of bitter taste or even promote the flocculation of particles containing bitter substances. Furthermore, many tannins possess antimicrobial properties, contributing to the disinfection of the water. The exact effectiveness of any of these mechanisms would depend on the specific nature of the bitterness of Maris's water and the concentration of the active chemical agents released by the plant. However, the immense richness of plant biochemistry and the diverse mechanisms that plants have developed to interact with water in their environment suggest that a natural solution is, in fact, chemically plausible. The tree may have functioned as a rudimentary biological filter or a chemical reagent provided by nature, whose application was revealed or intuited by Moses under divine guidance. This demonstrates that nature possesses its own complex and efficient purification systems, which modern science continues to explore and replicate. The idea that nature can provide effective solutions for water purification is not merely a historical curiosity. It is an ancient practice in many cultures around the world, and today, a vibrant field of study in environmental chemistry, biotechnology, and water engineering. If the miracle of Mara had a chemical basis, it foreshadowed many of the innovative approaches that modern science explores for water treatment, especially in context of sustainability, low cost, and accessibility. Let's delve deeper into examples of natural compounds and their mechanisms of action, which resonate directly with the event at Mara, showing how ancient wisdom converges with scientific innovation. One of the most prominent and well-studied examples is the use of Moringa oleifera seeds, often called the miracle tree, due to its multiple uses, including water purification. This plant, native to India and Africa, is a true natural purification laboratory. Its seeds contain cationic proteins which, when crushed and added to water, act as powerful coagulating and flocculating agents. Most suspended particles like dirt, clay, organic matter, bacteria, and even some viruses in water have negative charges. Moringa proteins attract and bind to these particles, neutralizing their charges and causing them to clump together into larger flocks. These heavier flocks rapidly settle to the bottom of the container, leaving the water visibly clearer, with turbidity reduced by up to 99% and an impressive reduction in bacteria by up to 90%. For bitter waters, if the bitterness is due to suspended particles or certain organic compounds that can be co-precipitated during flocculation, Moringa would be an ideal solution, not only for taste removal, but for potabilization, as it removes contaminants that affect health. Other polyphenols, such as tannins, are widely found in the bark, leaves, and fruits of various trees, including oak, acacia, and mangrove, many of which are native to or adapted to arid regions. Tannins are known for their astringent properties, which manifest through their ability to precipitate proteins and complex metal ions. In aqueous solutions, they can act as precipitating agents, removing certain heavy metals, alkaloids, or complex organic compounds that contribute to bitter taste and toxicity. Although in excess, tannins can impart a bitter and astringent taste themselves. In controlled concentrations or in combination with other compounds present in the plant, they could effectively neutralize the original bitterness of Maris waters. Furthermore, many tannins exhibit antimicrobial and antioxidant properties, adding an extra layer of purification and protection against pathogenic microorganisms. While not plants themselves, natural clays like bentonite and zeolite are minerals, with porous structures and remarkable adsorption and ion exchange properties. They can trap metal ions, toxins, and other impurities within their microscopic structures. Although the tree at Mara was not a clay, it is plausible that the plant used contained compounds with similar absorptive capacity, or that, upon reacting with water, formed precipitates that behaved as effective adsorbents, binding to the bitter substances. The use of activated carbon, a highly porous material produced from the incomplete carbonization of organic materials, is a well-established method of water purification worldwide, used since ancient times. Activated carbon possesses a highly porous structure with a vast surface area, giving it an exceptional capacity to absorb a wide range of organic and inorganic substances. This includes chlorine, pesticides, compounds that cause unpleasant odors and tastes, and even some heavy metals and toxins. Although the tree at Mara was not activated carbon itself, the wood of the plant, or perhaps compounds released from it, could have mimicked adsorptive properties, binding to undesirable molecules in the water of Mara. Modern scientific research, often inspired by ancient knowledge and the observation of nature, is dedicated to finding green filters and low-cost solutions for water treatment in underserved regions, where access to advanced technologies is limited. The tree of Mara, whatever its exact species, may have been a primal example of this applied natural wisdom, a fascinating link between divine providence and the intrinsic chemistry of life, offering an ingenious solution to a life or death problem that still resonates in our times. The episode of the waters of Mara transcends its biblical narrative to become a powerful paradigm for contemporary challenges of water scarcity and the pursuit of sustainable solutions for water treatment. The miracle of the tree that sweetened the bitter waters, when analyzed through the lens of chemistry and biotechnology, anticipates concepts that are today pillars of green chemistry and environmental engineering in the 21st century. The idea of using natural, renewable, and low-impact environmental resources to solve complex problems, especially in contexts of vulnerability and limited access to technology, is at the core of what we now call nature-based solutions. In the current global scenario, the water crisis is an undeniable and growing reality. Millions of people worldwide still lack access to safe drinking water, leading to diseases, social conflicts, and limitations to development. Conventional large-scale water purification methods often rely on complex and costly chemical processes such as chlorination, ozonation, and the use of synthetic coagulants. While effective in removing contaminants, these methods can generate undesirable byproducts, require sophisticated infrastructure, high energy consumption, and be economically unfeasible for isolated or developing communities. This gap in technology accessibility has intensely driven research into bioactive materials and biopurifiers as viable, ecological, and sustainable alternatives. The legacy of Mara invites us to explore and learn from nature more deeply. Biocoagulants and bioflocculants. Modern science has been dedicated to identifying and developing plant-based alternatives to synthetic chemical coagulants, which are effective, renewable, and environmentally friendly. In addition to the ubiquitous Moringa oleifera, whose seeds are widely studied for their cationic proteins that promote flocculation, extracts from the seeds of other plants, such as jack bean, Tamarindus indica, and even certain algae, are being meticulously studied for their remarkable ability to clump and settle suspended particles in water. The great advantage of these biocoagulants is that they are biodegradable, do not generate toxic residues, and are generally cheaper and simpler to apply in rural communities in emergency situations or in decentralized water treatment systems promoting community autonomy. The tree of Mara can be seen as the ancestral prototype of these modern biocoagulants, a testament to the inherent wisdom of nature. Natural filters and phytoremediation. The concept of using plants and natural ecosystems to remove contaminants from water, or to create large-scale natural filtration systems is gaining increasing traction in environmental engineering. Constructed wetlands, for example, are artificial ecosystems designed to mimic natural swamps, where specific aquatic plants are used to absorb pollutants, stabilize sediments, promote the biodegradation of organic contaminants, and improve water quality through complex biological and physico-chemical processes. These systems are highly effective at removing nitrogen, phosphorus, heavy metals, and even pathogens with a smaller carbon footprint. Although the situation at Mara involved a rapid and localized intervention, the fundamental principle that vegetation can chemically and biologically interact with water to purify it remains the same. Biomass adsorbents and biochar, agricultural and forest residues, often discarded or burned, such as fruit peels, seeds, sawdust, sugarcane bagasse, and even coffee grounds, are being transformed into low-cost and high-efficiency adsorbents. These materials can be chemically or thermally activated to exponentially increase their adsorption capacity for a wide range of pollutants, including dyes, heavy metals, pesticides, pharmaceuticals, toxins, and other organic compounds. This approach offers a circular and sustainable solution for water treatment, valorizing waste and creating high value-added products. The wood from the tree of Mara could, in a rudimentary and perhaps spontaneous way through released compounds or its porous structure, have acted as a natural adsorbent, binding to the bitter substances. The episode of Mara, therefore, is not just an extraordinary feat, but a powerful invitation to sustainable innovation and the rediscovery of natural wisdom. It reminds us that nature, in its intrinsic wisdom and vast biodiversity, often holds the keys to humanity's most complex problems. Moses' humility in following a divine instruction that culminated in the use of a tree is an inspiration for contemporary science to seek less intrusive, more environmentally harmonious, and, crucially, accessible solutions for all. The miracle of Mara, in this light, is a perennial lesson about nature's ability to heal itself and, by extension, to offer us the means for our own survival and well-being, provided we have the wisdom to observe, learn, and apply its principles. Even with all the prodigious advances in modern science, the sophistication of analytical and environmental chemistry, and the ability to simulate complex natural processes, the miracle of the waters of Mara still retains a profound fascination that transcends purely rational explanations. While we can, based on current knowledge, postulate plausible chemical and biological mechanisms for the water's transformation, the absence of specific details about the exact nature of the tree and the physico-chemical conditions of Mara's water constantly reminds us of the inherent limits to human understanding and the intrinsic complexity of nature. Science seeks accuracy, replicability, and controlled measurement. The biblical account, by its very nature, does not purport to be a scientific treatise, but rather a narrative of faith, providence, and overcoming adversity. There are fundamental aspects for which science, however advanced, can only speculate, without the possibility of direct empirical validation. Exact composition of Mara's water. What was the precise concentration of the contaminants that caused the bitterness? Were they specific salts, like excess magnesium sulfates or sodium chlorides? Were they organic decomposition compounds, like tannins or humic acids? Or perhaps the presence of toxic alkaloids from certain plants or cyanotoxins released by algae blooms? The absence of a chemical analysis of the original water prevents an exact replication of the scenario and the precise identification of the problem to be solved. Botanical identity of the tree. What specific botanical species was this tree or bush shown to Moses? The Sinai region, though a desert, has a diverse and adapted flora. The exact identification of the plant would allow for in-depth studies of its bioactive components, its mechanisms of action, and the optimization of its use. Without this crucial information, our hypotheses, however well-founded on natural parallels, remain in the realm of conjecture and generalization. Parameters of the intervention. What quantity of plant material was thrown into the water? Was it a small branch, a trunk, or leaves and bark? How long did this wood need to interact with the water for the transformation to occur? Was it instantaneous, or did it take some time? The reaction dynamics, water temperature, the ratio between the plant mass and the volume of water to be treated, all are critical factors that, in a scientific experiment, would be rigorously controlled, but which, in the narrative, remain unknown. Furthermore, the dimension of taste is intrinsically subjective and cultural. If the water became sweet, does this mean the bitterness was completely eliminated or merely reduced to an acceptable level for human consumption, making it palatable? And potability goes far beyond the simple elimination of bitter taste. It requires the removal or inactivation of pathogens and toxins that can be odorless and tasteless but extremely dangerous for long-term health. The biblical account primarily focuses on taste as a sign of potability, but it implicitly suggests that the water became safe to drink and not just palatable. The tree, therefore, would have needed to possess detoxification and purification properties that transcended mere taste alteration. Moses' act was not preceded by a complex laboratory analysis or a controlled scientific experiment. It was an act of faith and obedience to divine instruction. This leads us to reflect on the existence of deep empirical knowledge, an ancestral wisdom about the properties of plants and natural resources, which existed long before the systematization of modern chemistry. Could there have been a tacit understanding of medicinal and purifying plants that, over time, was lost or preserved and codified in religious narratives and oral traditions, awaiting to be rediscovered by science? The mystery of Mara, thus, invites us to a profound intellectual humility. No matter how much science advances, unraveling molecular and biophysical secrets, there always remains a realm of phenomena that defy complete decipherment. The universe is vast, intricate, and complex, and life on Earth manifests in countless forms, many of which we still do not fully comprehend. The ability of a simple tree to transform a vital resource from undrinkable to potable as immediately and effectively as described remains a powerful reminder of nature's ingenuity and the possibility that processes, substances, and interactions exist that we have yet to fully map, challenging our categories of knowledge. The miracle of Mara, therefore, is not just a story of overcoming thirst, but a timeless parable about the limits of our knowledge, the vastness of what is yet to be discovered, and nature's inexhaustible capacity to surprise us and provide solutions. It is a continuous invitation to wonder, curiosity, and the pursuit of understanding the deepest secrets of the natural world. The story of Mara defies reason and fuels curiosity. If a tree could turn bitter water potable, nature holds incredible chemical secrets. The miracle, whether divine or natural, invites us to look at the world with wonder and to seek sustainable solutions. What other mysteries does nature still hold, waiting for our curiosity to be revealed?